3m. For x, that's 3m. This is a simple exponential equation, a to the power of x equals to b, where a is greater than 0, b is greater than 0. And there is only one solution. Well, a is not equals to 1. This is a typo here. A is not equals to 1. So a greater than 0, b greater than 0, and a not equals to 1. And there is only one solution to the exponential of this form. Many exponential equations can be solved by expressing both sides to have the same, using the same base. Okay, that's the key to solve the question. Okay, we need to make both sides to be the same base. If you have the same base and you want both sides to be the same number, which means you need to have the same power as well. Okay, same power. So, for example, the first one, which is really easy, so 6x to the power of x equals to 6 to the power of 3, which is like make them to be the same base, and then you go to equalize the power x equals to 3. X equals to 3. 2 to the power of negative x equals to 1 on 64. Well, 64, okay, you can see 2, so your base must be 2. 64, okay, 64 is 8 times 8. In each 8, you have 2 to the power of 3, and each 8, that's 2 to the power of 3. So you have 2 to the power of negative x equals to 1 over 2 to the power of 6. But they still not have the same base. One is 2 and the other one is a half. So what I can do is I make that into 1 over 2 to the power of x equal 1 over 2 to the power of 6. I can do that as well. So x equals to 6. X equals to 6. Or what you can do, you can change this to 2 to the power of negative 6. So negative x equals to negative 6 and x equals to 6. Okay, for the next one, what we have is, well, 5. Okay, 25 and 1 to 5. The base must be 5. So that's 5 to the power of 2 and then to the power of negative x. And that's 5 to the power of 3. This side will be 5 to the power of negative 2x because you will times the power. You use the rule m to the power of a to the power of m and then to the power of n, that's a to the power of mn. So you have 5 to the power of negative 2x and 5 to the power of 3. Negative 2x equals to 3, x equals to negative 3 over 2. That's the third one. Okay, this one. 49 times by 7 will give you 343. I can show that here. So there are 2 sevens in 49, and then you have 3 sevens in 343. So I have 7 to the power of 2 bracket 2x minus 3 equals to 7 to the power of 3 and then to the power of 2x minus 1. So that's 7 to the power of 4x minus 6. When I expand the bracket, okay, 2 will times by 2x and also times by negative 3. And that's 7 to the power of 6x minus 3. So now they have the same base. Okay, they have the same base. So that's 4x minus 6 equals to 6x minus 3. So what I'll have is minus 2x equals to 3 plus the 6. So x equals to negative 3 over 2. And make sure you got all this question right. Okay, next one. Okay, 27 and 9, very obvious. 3 will be the good number. So that's 3 to the power of 3 and 3 to the power of 2 and then to the power of 2x. That's 3 to the power of 3x plus 9 and that's 3 to the power of 4x. Okay, times the power together. Remember to times the constant as well because the 3 will times by x and also will be times by 3. So 3x plus 9 equals to 4x. So x equals to 9. X equals to 9. Okay, next one. Well, if you can, well, I can see that definitely will be base 2, but like how many 2's are there? It's hard to count. But you can see 32. So 32 times by 4 will give you 128. You can see that easily, right? So what is 32? 32 is 4 times 8, and then times by 4. So you can see that 2 2's, there are 3 2 and there are 2 2's. So how many 2 we have in total? 7, right? 2 plus 3 plus 2, there are 7 2's in 1 to 8. So we will have 2 to the power of 7 and then to the power of 2x. Well, 32 there are 5 2's because 4 times 8, 2 2's and 3 2's, so 5 2's. And then x plus 3. We have 2 5x plus 15 equals to 2 14x. 5x plus 15 equals to 14x. 15 equals to 9x. Yes, sorry. Oh, 2x plus 3, thank you. That's 2x plus 3. And then here's 10x. We have 10x here, then 14, and then we have 15 equals to 4x. And x is 15 over 4 then. Okay, next line. Well, this one is 9. Well, 9 is 3 to the power of 2, and then x, and then we can see root 27. Cube root 27 is just a 3. 3 times 3 times 3 give you 27. So that's this. So we have 3 to the power of 2x equals to 3 to the power of negative 1. Okay, 3 to the power of 2x equals to 3 to the power of negative 1. So 2x equals to negative 1 and x equals to negative a half. Negative a half. Okay, next one. 2 to the power of x and 32 and 4th root. So we can keep the 2x because the base will be 2. 32 is 2 to the power of 5, and then we take a 4th root. So 2x equals to 2 to the power of 5 over 4. Okay, rational indices. You need to understand what's rational indices. The power will be the numerator and the root will be the denominator. So x equals to 5 over 4. Okay, next one. 3 to the power of x equals to, well, 27 is 3 to the power of 3, and you take the 9th root here. So 3 to the power of x equals to 3 to the power of 3 over 9. And x equals to 3 over 9, which is 1 on 3. Which is 1 on 3. You can simplify here, say that's a 1 on 3. Okay, last one. Last row is hard, and you have something quite similar to the last row. Okay, so the first one. Okay, the 1 is a really special number. Okay, the 1 is a special number because any base except 0 to the power of 0 will give you 1. So what I'll do is 6 to the power of 2x minus 6 equals to 6 to the power of 0. Because I just want a 1. So I can make both sides to have the same base as well, which is a base 6. So 2x minus 6 give you 0. And x will be 3. Okay, and x will be 3. Okay, this one, second last one is hard. Okay, I see like most of you can't get this right. So 3 to the power of x minus 2 over 9, 1 minus x. Okay, before what we only have one index numbers on the left and another one on the right. So we just have like two numbers that are equivalent. But now we have actually 3 index numbers. Okay, one divided by another one equals to the third one. So what we will do is 3 to the power of x minus 2 over, okay, 9 is 3 to the power of 2, and then to the power of 1 minus x, and that equals to 3 to the power of 2. I can see everything is to base 3, so I just change everything to base 3 first. And then the top one is 3x minus 2 over 2 minus 2x equals to 3 to the power of 2. Okay, what I can do here, I will use the formula a to the power of m over a to the power of n equals to a to the power of n minus n. I need to use this rule to do it. Well, for your interest, a to the power of m times a to the power of n will be plus, you know that. So we might can times the denominator to that side as well, or we can simplify directly here. So depends on you. I can just simplify here. So what I will do is, be careful with that step, is a 3, okay, x minus 2 minus a bracket 2 minus 2x, and that equals to 3 to the power of 2. Okay, be careful with the power, with the bracket. Okay, you need to use one power, subtract the whole thing for the other power. So you need to have the bracket there. So why I need the bracket? Minus 2 and then plus a 2x equals to 2. When I expand the bracket, that will become a positive. So 3x equals to a 6 and x equals to a 2. X will be 2 in this case. Okay. Okay, the next one. Well, I can practice the same thing, or this one is easy because I can say 6 to the power of 2 and then to the power of 3 plus 2x equals to 6 to the power of x. I can easily times the 6x to the other side and then equalize both sides. So I will have 6 to the power of 6 plus 4x equals to 6 to the power of x, and then 6 plus 4x equals to x. 3x equals to negative 6, and x is a negative 2 in this case. Have a negative 2 here. Any questions? Well, I think everyone tried last night, and you will have this type of question. Times to the other side. You times the same thing on both sides. Like this. Any other questions? You need to exactly know what's going on here. And if you get those type of questions wrong, I know you're not listening on the class. You can get one wrong, which like careless or something, but if you get all of that wrong, which means you're not listening on the class, okay? So that can reflect something. Just already telling you that's the type of question you will have in the test, so you need to be careful with those questions and you need to know and learn to that. Any other questions for this page? Okay, if not, I'll just save that first.